Let's see some of the important definitions required to solve problems in theory of computation. In this video, we will see the definitions of alphabet, strings, length of a string, empty string, substring, trivial and non-trivial strings, prefix and suffix of a string. An alphabet is a non-empty finite set of symbols. By this, I mean an alphabet cannot be an empty set and it cannot be an infinite set. For example, here we have sigma 1 which has symbols like 0, 1, 2, 3 till 9, and sigma 2 has some symbols from Telugu language which are finite. Sigma 3 has symbols like lowercase letters from A to Z, uppercase letters from A to Z, digits 0 to 9. Sigma 4 has symbols from Hindi language. So if you see, all these are finite and non-empty. An alphabet cannot be an empty set and it cannot be an infinite. Something like 1, 2, 3 and so on. This cannot be our alphabet because it is infinite, and this cannot be our alphabet because this is empty. A string is a sequence of symbols from the given alphabet. Let's say, for example, you have an alphabet A, B. The possible strings over this alphabet are A, BA, ABB, BABA, ABAAA, and so on. The strings like ABCD, DABC, DA, AD, these are not the strings of the alphabet because the symbols like C, D are not in the alphabet, so these cannot be the strings from the alphabet. The length of a string W can be defined as number of symbols in the string W. So the length of the string W1 is 1. Length of the string W2 is 2 because we have 2 symbols in the string. Length of W3 is 3 because we have 3 symbols in the string. Similarly, length of W4 is 4. Length of W5 is 5. Based on the length of a string, we can say a string is empty if the length of the string is 0. It is denoted by epsilon. So, if a string is empty, we can say the length of the string is 0. If a string is non-empty, we say length of the string is at least 1 or greater than 0. In this context, if W is a non-empty string, we can say W followed by an empty string is equal to empty string followed by W is equal to W. An empty string followed by an empty string is empty string itself. Let's see what a substring is. A substring is a contiguous sequence of symbols within a string. For example, we were given with a string ABCD. So, the substring of the string ABCD are A, B, C, D, AB, BC, CD, ABC, BCD, ABCD. Along with these, there is one more string which is empty string of length 0. This is of length 1, these are of length 2, these are of length 3, this is of length 4, and this is of length 0. So all these are substrings of ABCD. So we have 11 substrings. For a string of length 4 having distinct symbols, there are two types of substrings: trivial or improper substrings, non-trivial or proper substrings. Let's consider the previous example where string is ABCD. Let me write the complete substrings, set of substrings here. Epsilon, A, B, C, D, AB, BC, CD, ABC, BCD, ABCD. Given these substrings, trivial substrings are those which are the empty string and the string itself. So these two are trivial substrings: empty string and the string itself. Is called trivial substring, whereas the non-trivial substrings or proper substrings are those which are those other than trivial substrings. These are all called non-trivial substrings. Whereas non-trivial or proper substrings are those except epsilon and whereas non-trivial or proper substrings are those which are not trivial substrings. In this example, these substrings like A, B, C, D, A, B, B, C, C, D, A, B, C, B, C, D, all these are non-trivial substrings. So we can write, let's say, so we can write a non-trivial substrings is equal to set of all substrings we can say non-trivial substrings are set of all substrings minus trivial substrings, set of trivial substrings. Let's learn some formula for finding the number of substrings, trivial substrings, non-trivial substrings. Let's say W is a string with distinct symbols and is of length n. The number of substrings of W is sum of n natural numbers plus 1. The sum of n natural numbers came from the fact that we need to count all the strings of length 1, all the strings of length 2, all the strings of length 3, and so on, all the strings of length n. And this one came from the fact that we need to count the epsilon also, which is of length 0. So the number of substrings of W with distinct symbols, this is important. The W should have all distinct symbols. Then the number of substrings in W will be n into n plus 1 by 2 plus 1. The number of trivial substrings of W is 2. As we have said earlier that every string will have exactly two trivial substrings, which are empty string and the W itself. So the number of trivial substrings of W is 2. Number of non-trivial substrings of W is defined as the difference between the total number of substrings and the trivial substrings. So it comes out to be n into n plus 1 by 2 minus 1. The number of non-empty substrings which does not include epsilon are n into n plus 1 by 2. This is same as counting all the substrings of length 1, all the substrings of length 2, all the substrings of length 3, and so on and so forth, all the substrings of length n. We have seen as example earlier that the given string W is equal to ABCD. So here we found that there are 11 substrings including the empty string. So let's work out the formula here. Number of substrings is equal to n into n plus 1 by 2 plus 1. N here is equal to 4. The length of the W, length of the string W is 4, and the string has all distinct elements, distinct symbols. So we can apply this formula. So 4 into 4 plus 1 by 2 plus 1 is equal to 11. Number of trivial substrings, epsilon and W itself, so it is always 2. Number of non-trivial substrings is 11 minus 2, which is 9. So these lengths of 1, 2 and 3 constitute non-trivial substrings. Prefix and suffix are special types of substrings. These are special types of substrings. Prefix can be defined as the contiguous sequence of leading symbols in a string. For example, if we consider W is equal to A, B, C, D, then the prefix set will be epsilon, because empty string is a substring of every string. A, B, A, B, C, A, B, C, D. This is the set of prefixes. Whereas suffix is the contiguous sequence of trailing symbols in the string. So the suffix for the same string will be A, B, C, D, B, C, D, C, D, D, and epsilon. After understanding the definitions of trivial, non-trivial substrings, prefix, suffix of a string, we can see that trivial substring is both prefix and suffix. So here we know that trivial substrings are epsilon, and the string itself. So here, if you see, for that string W, prefix has epsilon and ABCD, the string itself, and suffix also has ABCD and epsilon. So a trivial substring is both a prefix and a suffix. Also, if the length of the string is n, the number of prefixes and the number of suffixes is equal to n plus 1. Here, n is equal to 4. That is, the length of string is equal to 4. So we have got 5 prefixes for the string W. In the same way, we have got 5 suffixes for the string W. So, if length of a string is n, the number of prefixes or number of suffixes is n plus 1.